Hello everyone, today I will show you how to design single photo frame with 34 meter length and overall height is 8.2 meter, and we design it by using Renet steel photo frame 0.3, and we have to do it quickly. Now we have to input the width of our structure, and spacing from one bay to one bay is 6 meter, and the total length is 42 meter, and height of the column is 6 meter, and we design it as the pin connection. And for the hole connection, we take it 10% of our length. Okay, 10% of 34 meter is equal to 3.4 meter for our hole connection, and the drop-spacing of column is 3 meter, and torsional strength of raster is 3 meter. Okay, for link spacing we use 1.5 meter, so to skip one per link, we add a torsional strength at the bottom of raster. Okay, and we can choose the Z. Okay, Z section is here to pass the deflection. Okay, now we have to select on the steel grade. We select 255, and the section you can select whatever you want. Okay, see here is the problem with visibility and the cross section. Then now we have to select this section, and for the section of raster we select IPE 500. Okay, and for the snow load in my region not applicable, no snow load, and we apply for the wind load only. And the wind load, we take the basic wind speed is 24 miles per second according to Euro code. Okay, Euro code. I'm not apply for the AISC. In the case we apply for the Euro code, you see here basic wind velocity N199114, and we select track category E2. Okay, you see here you can select 0 in the C. Okay, 1 in the with negligible orientation and without obstacle, but our construction site is in the type 2. Okay, in zone 2. Okay, and for the rock covering, we prefer for the load we apply 0.3. for the include for other load in include the still include the row cover and extra load at the top of the cover, and extra load we have to input 0.3 kilonewton per square meter for the roof cover. Okay, with other extra load. Okay, ceiling we not include here, we include to here. Okay, seismic not apply, but in this software, although you select the snow load 0, you will calculate the minimum snow load based on the 0 zone. Okay, and we have to select the plate thickness, strength of plate, and bar. Okay, you can select ball diameter. If you use smaller ball, we use the large amount of the ball, but we want to use that amount, we have to select the larger bar diameter. Okay, larger bar diameter. Okay, and we use a high grade for the steel connection. For the back connection we use lower grade, and everything here will be automatically calculated. You just input the parameter for the soil if you want to calculate based on the soil property, but in the case if you want to calculate based on resistance, you can input resistance. Okay, now you see solid property. Okay, solid property, select on solid property. You see your input solid property here, and you see here everything about our function. Apply. No, you can select train or untrain condition. Okay, and you can select the cover. Okay, concrete cover. I select 50. Okay, and grade or concrete footing. You can design according to the NHD or the zero code, and now you can select the diameter of the rebar you want to put in footing. Okay, you want to put footing, you can change the grade of concrete here and grade of steel here. Okay, now we have to calculate. Okay, and generate the report. You see the report will be automatically generated into you can convert it to the PDF file or to the Word file. Okay, now let's check. You use I want to convert to PDF. Okay, 75 page. Okay, you can convert it now. Converting to PDF file. You open it, and you see here for the column we use IPE 550, and for the raster we use IPE 500, and the width or texture is 34 meter length, and the overall height is 8.2 meter, and the column is 6 meter. Okay, and the direction is 42 meter, and this is a summary of design code and the basic information. Okay, your rows must be at least 7 degrees. Okay, minimum slope for the rows for the warehouse. Okay, it is the whole size. Okay, you see here 10% of 34 meter is equal to 3.4 meter. Okay, everything is detailed here, column section and column grade, steel grade. Okay, you see here description about the material. Okay, this part is description about load, apply load. Okay, automatic, although you input 0 in snow load, this software will be calculate the minimum snow load. Okay, you see here it is very small, 0.48 kilonewton per meter. It's very small. It is an alternative of the snow load. Big, small, big, small, small, big. Okay, you see the wind load. Okay, everything is calculated in this set. You see the apply wind load. Okay, on the raster, on the column, and the windward and the leeward. Okay, load combination, everything is more detailed here. Now I just to scroll down. Okay, about steel design, everything is here. This software is very good. Okay, you see about analysis, design about purlin. Okay, design purlin, design raster. Okay, for the ultimate. Okay, okay, everything is detailed here. You see design connection for the back connection, and this one is designed for the home connection. You see here at the ear. As you go to the earth, you will see about design of foundation. Okay, you see everything is detailed here. And for the one, the wave pressing system, we use a steer to press and each side of our structure. Like this one, you see at the earth, we use the L to pressing. Okay, you see here. And let's continue to last part is about the drawing. You see here the summary drawing of our structure, IPE, and this one is angle or slope or rose, and hold, okay, hold length, and the overall depth, okay, column height, position, scale, and length or width of the frame. Detail connection, you see here M27 and bolt grade is 6.8. okay, it is for the pitch at pitch it is at the ear connection. You see here this one for back connection. Okay, for back connection. Okay, detail connection. Okay, detail connection, and earn. Okay, earn. And now we have to verify it with Sovia Consteel. Now I apply everything the same with the Renet photo frame. Okay, let's open to the Consteel. It is geometry, and the width is 34 meter length, and the column height is 6 meter, and the overall height is the same with Renet, 8.2. okay, 8.2. Now I want to measure it. Okay, okay, you see here it's 8.2, and we want to review it at the 3D model. Okay, it is our frame section, and this one we use the column IPE 550, and this one is IPE 500, is the same with Renet, and we apply for the restraint. Okay, you see here it is restraint. Okay, in this column we have both restraint, okay, at the middle and above, and the raster we have here the restraint at the top and the bottom, and we skip to at the top bottom, in this portion we apply for the top only, because we distribute the purlin at the top of the raster in this portion 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here we apply the restraint for torsional buckling. Okay, and for other side is the same. Now we have to check about the load. we apply the load. Okay, we apply line load, we apply same with the RNet software. Now we have to check it. Okay, we apply it the same. Okay, apply it the same, and for the wind also the same. We want to verify with the RNet. Okay, you see here it's the same. Okay, now I had to analyze it. The analysis we include the initial space in the fiction of our structure, and now we have to calculate it. Okay, you see here the no relevant buckling result. Okay, it's good, and we had to check for the moment, the load combination, by you see here the moment is around 631 combination 1 465, and this one is 42, and you can compare with the RNet software about the internal force. You see here I will open with the PDS. It's more easy. Okay, sorry, we check with this one. For the moment, okay, you see it's around it's around 621. Okay, and this one is 631. It's almost the same. Okay, and now we have to check this one is the same, and internet is the same. Okay, and the location is 243. Okay, now we check is 243. It here is 250 OCT. Okay, in the location, and now we have to design in the conceal. Now we have to do it quick, and the next tutorial we detail how to analyze the photo frame. Okay, we run the check. We check for all local combination, and we have to perform calculation. You see here, this is the dominant calculation, the maximum one. Now you select the location of 101%. It is the percentage of our steel structure work, and the location is around 99%. You can check the percentage of steel. So you see here our structure is work almost 100%. Okay, if you compare with the conceal at the end of the hole, you see here the working is around 55%. Now if you check with the conceal. Okay, I check with the raster, global energy raster. Okay, at this one in the location, you see here the raster, and you will see the maximum percentage for the raster is 0.537. okay, it's almost the same with the count steer. Okay, with the count steer is okay, it's around 55%. okay, you see here it's almost the same with the count steer. And now because our structure not include joint, now we have to include joint. So when you input joint, the percentage will be reduced. Okay, now we have to include joint in our structure. Wireframe corner wizard. Now I have to perform, and I want to select this joint type. Okay, this joint type, and apply. Okay, you see here, we apply the joint in between raster and column to take it in calculation. We take an analysis, and we include the connection thickness. Okay, we include it in our calculation. Okay, let's calculate it again. And now no other relevant buckling result have to check. Now we want to quickly to analyze and design. For the detailed calculation we will do it in the time. You see the percentage will be around 88.4%. okay, you see here 88.4%. now you have check with the RUNET. okay, RUNET software about the column. Now I have to check with the column connection. You see here the column show a bending moment a column. okay, it is for the column design. okay, now we have to check at the column. okay, the column verification ultimate for IPL 550. okay, you can check everything here, and you see here the ultimate limit state verification for bending moment is around 0.95%. okay, indicate because we include the joint, so the percentage of the working load will be reduced to around 9%. okay, in the previous one is 100%. you see here it is designed in the noise software is 95%. now our structure is says it is very quick tutorial. now we have to introduce you about how to design the noise software and generate the port and verify it with the count steer. And for the tutorial we will do it detail, we will do it more deep. okay, thank you for your watching. Thank you.